So it says solve. It's not a proof. The same principles can be used in the proof. When it's solved, we're going to go to all the time. We're going to go, if it's more complicated, we're probably going to go equal 0 somewhere along the way. And we're probably going to maybe use fractions or get rid of fractions, and we're going to factorise somewhere. If it's in proofs, we can probably often use times by 1 somewhere, because we can use that to manipulate things. I look at this and I go sine cos next to each other. I can rearrange that to something else. And I can rearrange that to another form that I never memorise. Well, I shouldn't say never memorised. I have memorised and then promptly forgotten. And then I memorised again and then I promptly forgot again. So let's go back to it. You've got 4 possibilities and they're all written on your formula sheet. For those who don't have formula sheets, you know, it's written on your formula sheet and you look it up. Do you have that for the whole of the assessment, every assessment between now and the end of year 12? Yes. But in year 12 you'll have the year 12 formula sheet, not the year 11. Nice part is the year 12 one's not as long as the year 11 one. So I look up and I go, wait a minute, I want sine and cos. Well, by the way, why was I doing that? Why was I doing this thing? Here's the trigger. We want the trigger. This says 2x, this says 3x, and that says 1x. Vaguely in the back of my brain, I can turn a 3x and a 1x into a 2x using the formulas for that on our formula sheet. So before we were doing simple trig and then we were doing trig that had squares in it. This one is about how can I turn a 3x and an x into a 2x. So we go to our formula sheet and we've got a 4. I can go, every time it gets more complicated I always go square brackets. I've never sort of quite explained that to you. Now what does the formula say? Look at your formula, Ethan. And it talks about these things and it calls them A and B. Can you tell me the pattern of the formula? And you've got to get the correct one. Which is the correct one?
Sine A plus B.
Yeah, so it's a sine cos, so it's the third one down. So we're going to write. Now it's interesting, I said write a bracket, but this has got square bracket as well. So maybe I should write this. It's got a 4 times y. Here's the formula. It says to write half square bracket. What's it say to write next?
Sine A plus B.
Sine of add the angles. So A plus B is 4x. What else have I got?
And then plus sine A take B.
That's
so
going to be
2x.
2x. And what have I got now? So that's a 2. So that's 2 sine 4x plus 2 sine 2x equals root 3. Oh my goodness, this is going to be a shocker. No, it isn't. It's really, really, really easy.
2 sine 4x is root 3.
That's the same as that, yeah. So on this question, we do not need to go equal 0. We don't need that. Because it's not 2 equations with a parabola, or a weird parabola. It's just a normal everyday solve. So what makes it more complicated? 4x. What's my peekaboo method? Cover it over. Well, I actually cover over that. What x's will give us root 3 on 2? You see them in your head now? No, yes, no. So we want a root 3 on 2, so you go 1 into 2, 30 degrees, yeah? And that's a root 3. So using sine, which angle would give us a root 3 on 2? There's the root 3 on 2, that would be adjacent, so it's got to be this one. Because we're always talking about the sine there, opposite. I've got a video with mini-me. After a little me, looking across to there. So opposite is over there. So what have I got? Ignore the 4. One of our answers is 60. What's another answer? Got to go to all spaces. Central. So maybe Josh would do this and he'd go, I'm talking about 60, so I could go 60 there, go 60 there. Teaching this different little bit to how I was previously teaching. And you go, wait a minute, it's got to be positive though, so it can't be that one, it can't be that one. You okay, Matt? So what are our answers? I'm going to move this over a bit. 4x could be, remember I just ignored the 4. It's going to be 60 and next one. Here's 180. I'm going to go back 60. Okay. By the way, this is instead of drawing out the whole graph of sine 4x and figuring out where the answers are, this is a method of doing that. That's all it is. go further or do we go less? Go back to Marvin the Martian. So a half x would spread it out by twice, a third x would spread it out by 3 times. So this is not spread out, this is squished in. So that means by the time, this is what I never really explained properly. By the time we get to 360, instead of doing one loop of a sine, we're going to do how many loops? 4 loops. So I've got to figure it out. I've got to loop by there, loop by there, loop by there. So Matt, picking all those answers. So where was it root 3 on 2? What's root 3? It's about 1.7 on 2, so that's about 0.85 or something. So there is 1. So there's an answer there. So we're going to go 8 answers. And so far we've only got 2. I'm going to get rid of this for a second. What's the secret to it, Matt? Add 360. And then add another 360 and add another, and this is leading up to your question on the other topic. You start to see it now, little bit. So I could have done this, ready? What if I wrote it like this and I went 420 and I added 360 and I wrote 780? See, Matt, good thing about that, it's easier just to keep them in columns. Add the 360 and I got 14, 11, 40. Add 360 and I got 480. Oh my goodness, I still my head in. 840 in it. At 360 is 11, 1200. So there's all my answers. That one, that one, that one, that one, that one, that one. And what do we divide all the answers by? You write all them down. So often for a question like this, they'll say, let's make it 180, which is actually kind. And then next thing they'll write it in radians. That makes people up. You might notice I'm nagging about degrees all the time about radians. Good part is that we did that one, I'd only have to do that. So I could have then just gone that. You're right now. Because add 360, 420, add 360. So I could have written that there if I wanted to, and done that 480. And now I've got to go quarter of them, so that will be 15, that will be 30, that will be 105, and that will be 120. Done? So it would have been kind if we did 180, wouldn't it?